Hello all. Today our discussion will be continued on Introduction to AC. AC or alternating current. So far our discussion was carried out with DC analysis where the current was direct or unidirectional rather I should say. So the basic of AC is that the magnitude of any signal, that may be a voltage signal or current signal or both, that changes with respect to time. So for DC, the value was constant throughout irrespective of time. So this is DC. But if somehow the magnitude is changing, although the polarity remains same, so we can say that unidirectional. Now, a signal like this, which changes its magnitude in both the ways, so it is bidirectional. Or I should say alternating. That means with change in time, the magnitude changes in different directions. Okay, like a triangular wave. That is also a AC nature. Okay, so with respect to time, the magnitude changes. That is the basic of alternating. Now, for our analysis, we will assume sinusoidal signals for the sake of the analysis. This follows a sine curve. Okay, so sine and cosine curve is treated for our analysis. Okay, so basically we can say AC means magnitude and direction changes with respect to time. We will assume we will carry out sinusoidal for the sake of our analysis. Okay, so this is one sinusoidal signal. Suppose this is a voltage signal given by VT, graphical representation. Also assume that there is a current signal or another voltage signal. There is only a certain advancement or okay. So there are two signals. If I refer this signal A as Vt, how do I mathematically represent it? I represent it as Vm sine omega t, where the distance from the mean value to the highest value, that is Vm, the maximum displacement, that is Vm. Omega t is the on the time axis. Okay, so your omega t axis. This is your omega t axis. This is your magnitude axis. This part is your Vm. You know it. Now, Vm is maximum voltage, that is Vm. Omega, this is called angular frequency given in rad per second. This is given in volt. T, what is T? T is the time period. Okay, time period means you can see that after this point, so this is called pi or 180 degree, this is 2 pi or 360 degree. See, after 2 pi, the waveform again repeats itself. So this type of waveform is known as periodic waveform, and the property is known as periodicity, which the waveform shows. And after which time after certain amount of time the signal repeats itself. So after here in this case, after 2 pi, the signal again repeating itself. So this 2 pi is the time period t. So in a GIS, time period means that after a periodic signal repeats itself after a certain interval of time. That time interval is known as time period. And from this zero, let me show it through a different ink. From this zero to this zero, the whole thing is known as one cycle. Okay? So in 1 second, if n number of cycles are observed, so that will be called as frequency. So in 1 second, how many cycles you will be seeing for a particular second signal, that amount is known as its frequency. Okay? That is t equal to 1 by f and f equal to 2 pi by omega, where omega is this omega, angular frequency. Okay, so t is the time period that we are talking about. Obviously, it is given in second, and it is 1 by f, 1 by frequency. F is frequency. Okay, so f equal to 50 hertz for an AC signal. For DC, f of DC equal to 0, because you know that for a DC signal the magnitude is constant, so there is no chance of repeating itself. It is always same. So there is no chance of frequency. Frequency means at what amount of time, or at 1 second, how much repetition is observed. There is no chances of repetition. That's why f in a DC signal is 0. So frequency of DC signal is 0. That is very important concept. Okay. So coming back to the discussion, what do we mean by 50 hertz signal? It means 50 cycles in 1 second. 50 cycles, 50 such complete cycles will be observed in 1 second. Okay. So what is the time for 1 cycle? So if we see 50 cycles in 1 second, so 1 cycle will be observed in 1 by 50 second, or in other words 20 millisecond. So the amount of time to observe 1 cycle, that is known as time period. Clear? So this is the basic concept. Now one important thing you should know, that is, in AC signal, whenever numericals will be given, some format will be given to sine and some signal will be given to cosine. So you need to know the conversion technique between sine and cosine. Okay. First, sine 90 degree plus theta. Second, sine 90 degree minus theta. Third, cos 90 degree plus theta. And fourth, cos 90 degree minus theta. So remember that. Remember this graph. Okay? We are taking x-axis and negative y-axis. So sine 90 plus theta. Again another thing. Positive anti-clockwise is positive. Anti-clockwise movement is positive, whereas clockwise movement is negative. Okay, so now sine 90 degree plus theta, that is always cos theta. Sine 90 degree minus theta, see, that is also cos theta. Cos 90 degree plus theta, that will be equal to minus sin theta, and cos 90 degree minus theta, that will be sin theta. Okay, now there is a technique to you have to memorize them, and if you are having any difficulty in memorizing them, just tell me. I will give you one shortcut trick for that. Time will not permit right now. But again, if you are interested in sine to cos, cos to sine conversion, to make it more, there is one trick. I will tell you later. If you are interested only. Okay. Now, whenever we deal with AC, there are two ways. One, magnitude phase relationship. Another is, this is also called polar form. And another is complex or Cartesian form. Okay. You are aware about that polar form in machine or some problems you might have carried out here. Okay. So say suppose we are talking about 10 angle 30 degree. So that means the signal having magnitude 10 degree and phase 30 degree. So we represent it as cos 10 cos omega t plus 30 degree. On a similar note, 10 minus 45 degree, we represent it as 10 cos omega t minus 45 degree. Okay. This is the polar form. In the other way, 10 plus j 30. This is Cartesian representation. And I think you know the conversion between them. You have gone through 10 plus 2 level mathematics. There you have studied how to convert Cartesian to polar and vice versa. In this regard, let me tell you one thing. In case of DC, we stated that capacitor in steady state was open circuited and inductor in steady state was short circuited. But in case of AC, and there was a concept of resistance. Ohm's law was mathematically written as V equal to IR. Now, in AC, instead of resistance, we will write two things. One thing, that is impedance. Ohm's law becomes V equal to IZ. Here R was resistance, here Z is impedance. Impedance consists of two parts, R plus JX. X is called reactance. Now the reactance may be capacitive or inductive. For capacitive inductance, Xc we will write, that will be represented by 1 by 2 pi Fc, where F is supply frequency like 50 Hz, 60 Hz, etc. And for inductive we will write XL equal to directly 2 pi f L. In other words, xc is written as 1 by omega c, because you know omega is equal to 2 pi f. On a similar note, xl will be equal to omega L. Okay. Now in a circuit, impedance can consist both inductive and reactive capacitive impedance. So in that case, we write it J of XL minus XC. If XL is greater than XC, then uh, we write it in this way, R plus J into X. Okay, if XL is greater than XC, also it can be written as R minus J into XC minus XL, or in other words, R plus J into XC minus XL when XC is greater than XL. In the first case, inductance is more, that's why this positive sign is there. So this is called as inductive circuit. When inductance is more, that will be inductive circuit. And here this case, in this case, you will see that capacitance is more, so it is a capacitive circuit. Now Ohm's law will be treated as V equal to I Z. We have seen it in the previous slide. V equal to I Z. Okay. So I can give you one very simple example how to solve the network problems. And remember one thing, I am writing it in black ink. Nodal mesh analysis, KVL, KCL, all network theorems like superposition, Thevenin, Norton, etc. are equally applicable for AC analysis. Okay. Now let me give you one example how to tackle network problems. Here you should notice one thing. This Z is represented R plus Jx. This is resistance as usual. This is reactance as I have already mentioned. So any reactive part will be represented by some imaginary magnitude. So J2 means it is an inductor, and J2 means it is inductor. So it is Cartesian representation. Cartesian. Now if I would have written 2 angle 90 degree, J is what? J is, suppose this is real axis, this is your imaginary axis. So j means in this axis. So from real axis you have to move 90 degree anti-clockwise. So that means positive direction. So that's why 2 and positive 90 degree means the same thing j2, but that is now in polar form. So these things you have to keep in your mind. Suppose this is 2 and this is also 2, this is j2. Now the value of the voltage is given as V1 equal to 20 cos, suppose 40 cos 100 t plus 60 degree. So I want to solve for I, and I have to apply nodal analysis. So there is one node here. This node have the same voltage. This node is the ground node. There is no other elements. So this thing can be written as 40. You see 40 cos 100t plus 60 degree. So this is represented as 40 angle 60 degree. Okay. Now nodal analysis, suppose this is node A. So what should we write? We should write that 40 angle 60 degree minus VA divided by 2 equal to VA by 2 plus VA by 2J. I am applying nodal analysis. So incoming current equal to outgoing current. So this is incoming current and these two are outgoing currents. So I have followed that convention only. So if you solve, you will get one result. I am not doing that. So this is the way I am just showing. You need to practice by yourself. Okay? That was I was trying to show. So similar problems you can pick up from any standard textbook. If you are unable to find, you just tell me, you just communicate me, I will give you some problems from there. Okay, so don't worry with that. Now for you need to remember one thing only. When multiple frequencies are there, superposition is valid for only one particular frequency. I am giving one example what I have said here. Suppose a signal is there, V equal to V, okay, say 10 cos 30t plus 20 cos 60t plus 10 cos 90t. So here you see three different frequencies are there, omega 30, omega 60 and omega 90. The smallest one is known as fundamental, and other frequencies are known as harmonics, which is generally integer of the fundamental, integer value of the fundamental. But here in this case, you cannot write it on say 10 angle 30 degree plus 20 angle 0 degree. Okay, so here 10 angle 30 degree, 10 angle 0 degree. Why? Because there is no phase difference. Phase means what? I am writing in very first slide. Phase means if you take the starting of this signal from 0, this is your standard waveform Vm sin omega t. Right now, the same signal, if I have shifted in the time axis by left side, I have just shifted the signal. See, now this is your pi, this is your 2 pi point. I have just shifted the same signal. By shifting, some displacement is observed. This point has been shifted to this point. So this displacement is known as phase, and it is given by Vm sin omega t plus or minus phi. Okay. If I move towards left, there will be negative. If I move towards right, it will be positive phi. So negative side means signal is advanced, and in positive side means signal is delayed. Okay. So the concept of phase is also required. Phase. Delay means positive, advance, negative. Okay. Now in some signal, suppose 100 cos 60 t. Here omega is 60 degree. I can write it as 10 angle 60 degree. But 100 cos, okay, let's go with this example. There is some problem here, isn't it? Okay. Here you can see that let's use this signal. Okay. I am assuming that the fundamental I should represent it phasor form, so it will be 10 angle 0 degree. But whenever in a complex signal I have already represented the fundamental in phasor form, I cannot represent the other harmonic component in the phasor form. That is the disadvantage. So in that case, you have to treat each signal separately. So you have to take the concept of superposition. First you do your analysis by considering this part only, then you continue your problem with this part, then with the third part. So that's how the superposition theorem in AC will work when multiple frequencies will be there. And voltage and current of different frequencies cannot interact with each other. That you have to remember. Now, with respect to this signal, suppose I have one signal known as 10 cos 30 t plus 60 degree. Now I can represent that signal because the frequency is same. That's why I can represent the phasor. Suppose it is say 20 cos. So now I can write it as 20 angle 60 degree. Okay, because omega is fixed at 30. So that is the thing that I want to mention to you. Okay, so you can consider the problems and you will check it, you will verify all the things from there. Okay. Now some important things regarding the AC I would like to mention. Point number 1. If nothing is mentioned, consider RMS value. Like suppose a source is given, the voltage is given as 100 volt. So you might get confused that this 100 is 100 sin omega t or some 100. So in that case 100 should be your RMS value if nothing is mentioned. So in that case your representation will be 100 into root 2 sin omega t. Okay, why 100 root 2? you know that in case of any AC waveform, if the maximum value is, okay, for a sinusoidal waveform, if the maximum value is Vm, then V average equal to 2 Vm by pi, and V RMS equal to Vm by root 2. That is known to you. I am not going into the detail. Okay. So this will be taken as RMS value. Next one. Suppose in a problem it is given as Vt equal to 10 sin 30 t plus 60 cos 30 t plus 60 degree. Now here in this case, either you have to take, obviously one is sine format, one is cos format. Now from the second slide, third slide, I am confused or whatever. Yes, here in this slide, I have given you some formula for from converting sine to cos or vice versa. So whenever a mixture will be there between sine and cos, you have to utilize that, and you can take any one as a reference. Either sine will be reference or cos will be reference. If cos is your reference, convert this sine to cos, then do your analysis, or vice versa. But if Vt equal to 10 sine 100t is given, then you take your 10 sine, okay, 100t plus 60t is given, then you have to take your reference as 10 or whatever you can take as sine 100t as a reference. Similarly, in a problem, if it equal to 20 cos 60t minus 45 degree, this is given, then you have to take some cos 60t as your reference. Okay. Next, so it depends on what is given to you, and you have to take the reference based on that. Okay. So in case of sine, only you have to take the sine form as reference and compare to it. You have to analyze. In case of cosine is given, you have to take a cosine format as a reference and do the analysis. And in case of a mixture is given, you can consider any of them and convert the other to the previous one and do your analysis. Okay. So that's about the basic regarding the AC fundamentals. Now we will be focusing on an important concept, that is phasor diagram. Okay. Very important thing. Very important. Phasor diagram. Very important. So obviously in phasor diagram we will consider the polar form. So one part is magnitude, the other part is phase angle. Okay. Already I have given that V angle theta, here V is your magnitude part, theta is your phase part. Okay. So I can give this explanation with the diagram, with one diagram. Let me draw a diagram. Now, you see, at each point, if I do the phasor diagram, theta over here, magnitude over here, so that will be a phasor diagram. So at each point, some magnitude is there. At each point, some magnitude is there. So with respect to one particular instant, some magnitude points are there. Okay. Now, in few slides back, I have given that xl equal to j into sorry. Let me write it the other way. J equal to r plus jx. In other words, r plus j into omega L. Okay. So basically, J is written as R plus XL if it is an inductive circuit. Okay. So XL equal to J into X. X into XL equal to J into omega L. Now, if I represent it in magnitude term, so it will be magnitude value will be omega L and angle will be 90 degree. Now, if I represent XC on a similar way, which is actually 1 by j omega c, and 1 by j is also known as minus j by omega c. So, its magnitude part will be mod of 1 by omega c, that will be magnitude part, and phase part is minus 90 degree. Clear? Now we will consider few different circuit approach. First one is series RL circuit. Series R circuit already known to you, that will be DC analysis, similar to DC analysis. So let us draw one circuit for the sake of analysis. So this is your supply. Now in case of DC, we represent through a battery. This is positive plate, this is negative plate of the battery. In case of AC, we represent the source by this symbol. Whether it is current source or voltage source, whatever, the symbol is this one. So this means DC, this means AC. And if you want a clear differentiation between DC, another thing I need to tell you that IV, that means generally, that is not a rule, but I am saying a generalization. Capital letter AC, I and V. That means small letters DC. Okay. Anyway, so let's get back to our circuit. We are talking about a series RL network. So this is your R, this is your L, this is current flowing through here to here. So right now, the KVL will be applied in phasor form. If this voltage is V, so actually the V in phasor form, we represent it mathematically by an arrowhead, just like vector. We treat phasor just like a vector, but the name is phasor. In case of vector, there are magnitude and direction. In case of phasor, there is magnitude and angle. So voltage in resistor plus voltage across inductor. but that is not algebraic summation. Just like DC, that is unlike DC, it is not algebraic summation. It is phasor summation. Just like scalar addition and vector addition. So here are the differences. So VR through Ohm's law, it is known that VR is equal to IR and VL equal to I into XL. Okay. So that can be written as I into J of omega L in magnitude format, I into omega L, that is magnitude, and positive J is here, so it is plus 90 dB. Okay. So what will be the reference? So your reference will be I into j omega L. So the reference will be if nothing is mentioned, I can put anything. So I am just assuming a sign Vm sine omega t. This V into root 2, that is equal to Vm. Nothing is mentioned, I have assumed sinusoidal. If I could assume cos, that the analysis, the formula should be different, but the analysis would have been the same. Okay. So now this is the scenario. You see that voltage is Vm sine omega t and current is Im sine omega t plus or minus phi, because R and A is there. Okay. So I am representing through phasor diagram. See, this is my I. It is a series circuit. Current is I. Current is I. It is a series circuit, so current will be same in both the elements. So in series circuit, current is the reference phasor. Okay. So current is in reference phasor I. Now in resistance, there is no phase difference between voltage and current. Whenever inductor, okay, I am writing that too. In case of inductor and capacitor, plus minus 90 degree phase shift between voltage and current takes place. Okay. So this is the I. What I was, let's get back to here. I is same through these two elements, R and L. Now there are two more elements. One is resistor, and in resistor there will be no phase difference between voltage and current. So to some scale, let me suppose in some scale this is a voltage drop, voltage across resistor, and here VL we have seen the phase difference is plus 90 degree. So VR plus 90 means anti-clockwise 90 degree. So somewhere here, depending on certain scale, this will be VL, and KVL means what? Phasor addition, just like vector addition. This is your VR. Okay, this is not actually 90 degree, but actually it should be 90 degree. Okay. So phasor addition of VR and VL, just like vector addition. So this will be V. This will be V. This V. So VR plus VL. So that's how phasor diagrams are drawn. Okay. This angle is known as phi. Phi is known as power factor angle. Power factor angle phi. The angle between these two. Okay. So cos phi is equal to, what is cos phi? VR by V. VR by V, that is cos phi. Okay. Now one thing is, I think you can notice tan phi equal to VA by VR. So phi equal to tan inverse XL by R. Why? Because VL is I into VL equal to I into XL and VR equal to I into R. Okay. So this is all about RC series circuit. In the next we will be discussing about series RC circuit and other associated elements. Thank you.